Hi, so for today we're going to talk about 1001 solved integrals part 17, and we are going to discuss four problems here as we have four problems here for the power of secant, tangent, as well as cotangent and tangent. Okay, so let's get started. So for the first problem, we have secant raised to 4 beta, d beta. Okay. So the very first thing that we are going to do here, we can separate this in to 2. Okay. So that this becomes secant squared beta multiplied by secant squared beta d beta. So that's the very first thing that we're going to do. The secant squared beta d beta on the right side, we will let it as it is. And we are going to transform this into Pythagorean theorem. And if you remember, we have 1 plus tangent squared of x equals secant squared of x. So that's what we are going to do here, so that the variables only change from x to beta. So we're going to change that. So by changing that, okay, we have 1 plus tangent of squared beta, and then we have secant squared beta d beta. So why did we do this? So that if we let u as the tangent here, tangent of beta, the derivative of tangent would be secant squared beta d beta, which is readily available here. So that we can now use the u substitution, so that we have 1 plus u squared. Take note that it is squared, so it must be raised to 2. Okay, and then we have du here as our secant squared beta d beta. So we simply use u substitution. So it's very easy. We can distribute the integral sign in the du. Okay, integrate this. That would be u plus u raised to 3 all over 3 plus c. But our u is tangent of beta, so we can transpose that or back substitute it. So we have tangent of beta plus 1/3 of tangent of beta cube plus c. So that will be our final answer for this problem 104. It's pretty easy, right? So we just have to remember the identities. Okay. So for number 105, we're going to write another problem. That would be secant squared x. And then we have tangent of cube x dx. Okay, so again, what we're going to do here is very straightforward, because if we try to switch, okay, we have tangent of cube x, then secant of squared x. This speaks of that we can let u as tangent. Okay, tangent of x, because the derivative of tangent again is secant squared x dx. So now we can simply let u. We have u raised to 3 because of the cube here, and simply we have the du here. So simply that would be u raised to 4 all over 4 plus c, and then we have tangent of raised to 4 of x all over 4 plus c. So this will be our final answer for this simple integral in the power of secant and tangent. So that's always the goal. The goal is if we can separate, okay, one strip of the trigonometric function. In this case, no need, because we have secant squared here, and the derivative of tangent is secant squared. So I simply just switch the two via associative property, and then we can clearly see that we can just simply let u in this problem. Okay. So for the problem number 106, so let's try. We have 106, problem 106. So that's the problem. We have the integral of cotangent of 4y dy. Okay. So the very first thing that we're going to do here again is we have to take advantage of identities. No? So what we're going to do first is we are going to rewrite this as cotangent of squared y, and then we have squared dy. That is the same as that. So I just put it into exponential form that if you simplify, it is still the same. So taking advantage again of the Pythagorean identities for the cotangent, so we have cosecant squared y minus cotangent of squared y equals 1. Okay? So if I'm going to substitute it, so I'm going to get cosecant squared y minus 1 equals cotangent of squared y, of which I can simply substitute. Okay? So cotangent squared y is simply equal to cosecant squared y minus 1, and then I have the squared. Okay? But before that, before I change it, let me just rewrite this as this so that you will not be confused. Before I change it, so it's raised to 2, so I can have cotangent squared y and then cotangent of squared y. Okay, before I change. So I'm going to change just 1. Okay? Just 1. So we have cotangent squared of y, we have cosecant squared of y minus 1 multiplied by cotangent squared of y dy. Alright. So if I'm going to do that, that will be the case. Okay? So, but my question is, what's the point of doing this? Okay? If we can not find a pattern in our integral. Because if we just simply substitute it or distribute this, we will be ending up in this. Okay? Still, cotangent of squared y for this term. So, might as well, I'm going also to change this. Okay? So, we are just looking at the different patterns here, right? So that we can understand it better. So, I have the integral of cosecant squared y minus 1 and then cosecant of squared y minus 1 dy. So, if I'm going to simplify it, I can FOIL, right? So if I FOIL that, okay, and you use the products, so I will be arriving at cosecant raised to 4 of y minus 2 cosecant squared y and then plus 1. Okay, that will be my expansion of this product. And again, continuing on to our discussion, this is raised to 4. So I can technically say that cosecant raised to 4 of y would be cosecant squared y raised to 2 minus 2 cosecant squared y plus 1. So I did that, okay, to again simplify our raised to 4 into squared, because we know that if we squared that, okay, we will be able to see a identity here. So again, furthermore, if I'm going to spread this 2 cosecant such that I have cosecant squared y here multiplied by cosecant squared y. So this term is this term only. Okay? Minus 2 cosecant squared y plus 1 dy. Okay, I just split it up. Okay, and one of them I'm going to replace. Okay, one of them I'm going to replace again. So by our identity. And what's our identity? Cosecant squared. Okay, we have cosecant squared here. I'm going to isolate cosecant squared here. So I'll be having 1 plus cotangent squared y. So I'm going to substitute it. 1 plus cotangent squared y. And then you have cosecant squared y minus 2 cosecant squared y plus 1. Okay? You seeing what I'm saying here? Okay, it becomes more easier to solve. Okay, because we have different trigonometric identities instead of just cosecant squared. We have cotangent again. So if I'm going to distribute, say I'm distribute this, okay? So I'll be having what? I'll be having cosecant squared y plus cosecant squared y cotangent squared y minus 2 cosecant squared y plus 1 dy. So before I continue, if you're going to notice, we have cosine squared y minus 2 cosine squared y. So we can simplify it as just negative cosecant squared y. In other words, it's just algebra, right? So because they have the same term. So this will be disappeared, and this negative 2 will become negative 1, or simply negative cosecant squared y. So we'll be having cosecant squared y cotangent squared y minus cosecant squared y plus 1. Okay, we are left with that. And again, by simplifying this and this, so it minus, we get the difference of that too. Okay, so now we can now just simply get the integrals. So I can separate cosecant squared y cotangent squared y dy minus integral of cosecant squared y dy plus the integral of dy. So I can now separate. So if you may notice, we can let u substitution here. Okay, we can let u as the cotangent of y. And we know that if we get the derivative of cotangent, the resulting derivative would be negative cosecant squared of y dy, of which we have already cosecant squared y dy here, so that we are going to have negative du here, transferring the multiplying both sides by negative 1 of the equation. So you have cosecant squared y dy. Okay, and this is readily integrable. We have a formula for cosecant squared y, which is the cotangent, and this is readily integrable also. So if we do that, class, we have u squared because of the cotangent squared, okay, and then I have negative du here because of the cosecant squared y dy equals negative du. Okay, so and then I integrate negative cosecant squared y, that's cotangent of y. Okay, that's simply the cotangent of y. And then integral of dy, that's plus y and then plus c. So now you have negative u raised to 3 all over 3 minus cotangent of y plus c, or in other words, we have negative cotangent of cube y all over 3 minus cotangent of y plus c. Okay, so that we have now our final answer for this problem 106. Alright, so this will be our final answer. Okay, so that's quite length of a process, but if with a practice, we can perfect, okay, the solution of this integral. So it takes experience and practice to do this. Okay, for our last number, okay, ready yourselves because this is somewhat long also. So we can get the integral of tangent of raised to 5x dx. Okay, so again, in the technique in this is that we can split it into one even and then one odd power. So in this case, if that is 5, we can strip them into tangent of cube of x and then tangent squared of x dx. Again, why we are doing this is that because we want the squared or the tangent of squared. Okay, by Pythagorean, we have 1 plus tangent squared of x equals secant squared of x. We have to find a way to extract different trigonometric identities here so that we will be able to solve this type of problem. So we have equal integrals of tangent of cube of x multiplied by the if that is we are seeking for tangent, So tangent squared of x from this equation, identity, that would be secant squared of x minus 1. Okay, so we'll be doing that. We have secant squared of x minus 1, and then we have dx. So as you can see, if I'm going to distribute this, okay, there's a chance that we can use u substitution because tangent, derivative of tangent is secant squared. So if I do that, that would be tangent of cube of x, then secant squared of x dx minus 1. I'm going to multiply tangent cube of x with minus 1. So I have tangent cube of x here, dx. So this has no problem. Okay, if I'm going to let u, let's try to let u, tangent here of x, the derivative of tangent would be secant squared dx, of which we can just simply substitute. Okay, in this part of tangent cube of x, we cannot integrate it right away because we're going to strip off another squared there, tangent squared, and then do the same process. So if you do this first for the first term, so we have u raised to 3, then we have du minus integral of tangent of cube of x dx first. So this would be u raised to 4 all over 4 minus the integral of tangent of cube of x dx. So going back to its original form, u is tangent of raised to 4 of x all over 4. So let's now focus on the second term, which is the tangent of cube of x dx, because we are done with the first term. We have already gotten the answer for that. So the same technique that we are going to apply for the next term, I have tangent of x here multiplied by tangent of squared of x dx here. And applying the same identity that we have applied a while ago, we can substitute tangent squared of x as secant squared of x minus 1 and then dx, and do the same process. So I have tangent raised to 4 of x all over 4 minus, distribute this. Okay, distribute. So I have tangent of x secant squared of x dx along with the integral sign and the dx sign, of course. And don't forget the negative. Okay, so if I'm going to transpose negative integral of tangent of x with minus 1, so that also becomes what? Positive. Okay, so it becomes positive. Okay, integral of tangent of x dx. Okay, so again, for you not to be confused, you can first distribute it without the negative sign. So tangent of x, secant squared of x. So you'll be getting this with a minus here. Okay, because of the minus here. So that if you start to distribute this, all right, so this would be negative, and negative of negative, if you distribute this, this would become positive. All right, so that's the, so just to clear. So we have tangent of raised to 4 of x over 4 minus, so if I'm going to let u here, same process, let u of tangent of x du would be secant squared of x dx. So we can just simply what? U substitution here, u du, and then okay, plus we have tangent is sine of x all over cosine of x. That is already readily integrable. Okay, we know that, but I just show you the integral of tangent of x. So we have minus u squared all over 2 plus, if we let u, if we are going to let u, okay, as our cosine of x, our du would be sine of x dx, negative sine of x. So negative du would be sine of x dx. That's just simply u substitution. So I have now sine of x dx is negative du sine of x dx all over cosine of x, which is u. So I have now the answer. I have tangent of raised to 4 of x over 4 minus, okay, u squared, that's tangent of squared of x all over 2, and then minus ln, okay, minus ln of u, because du all over u is ln. So going back to its original variable x, we have now tangent of square root of x all over 2 minus ln of cosine of x plus c. And this will be our final answer for this problem. And I hope you guys learned something today. Thank you so much for listening. If you haven't subscribed to my channel, please do subscribe to my channel to learn more about math and engineering subjects, tutorials. So I hope this video helps you in your studies. And please don't forget to subscribe. So see you again on the next video. Thank you.